Välkommen till dagens webinar där vi ska prata om monoförbränning och fosforåtervinning. Nina Lövgren heter jag och jobbar med marknadsföring på Huber. Idag kommer det bli ett lite annorlunda webinar då vi har engelsktalande gäster med oss. Så vi får se hur detta går, men det tror jag ska bli alldeles fantastiskt.
Det löser vi.
Det löser vi. Och med oss idag då så har jag min kollega Pontus Hallbäck. Vi har Liubov Vasenko från Easy Mining och sen har vi Dr. Heindl från Huber. Dr. Heindl, can you hear me?
Yes, I hear you.
Perfect. Welcome to our webinar.
Nice to meet you.
I understand you are one of the persons who knows most about sludge at Huber. Can you please give us...
I have some knowledge about sludge treatment. Yeah. So,
and can you please give us a short introduction about yourself?
Yes, my name is Albert Heindl. I'm working at the Huber SE in Germany since more than 12 years in the technology department. I'm responsible for research and development in sludge treatment, starting with dewatering sludge, going on with drying of sludge in disc dryers or belt dryers or soda dryers, and ending with the incineration of sludge in fluid-based incinerators.
Thank you very much. We're glad to have you here. Our other guest for today is Liubov Vasenko from Easy Mining. Welcome.
Thank you. It's a pleasure to be here.
Can you tell us a little bit about yourself?
Yes, my name is Liubov Vasenko. I have a background with research and development within the phosphorus recycling from wastewater treatment systems. And since the last 2 years, I'm working as a process engineer at Easy Mining, working mostly on ash-to-phos process for recycling of phosphorus from sewage sludge ash.
Thank you, Liubov. Happy to have you here. Och till sist så har vi också min härliga kollega Pontus Hallbäck. Pontus, vad är din roll på Huber?
Tack Nina. Jag jobbar med affärsutveckling i Norden där mina huvudfokus är energiåtervinning, torkning av slam och monoförbränning.
Härligt, det kommer bli ett spännande webbinar tror jag. Men först så kan vi ta lite teknisk info. Och som vi nämnt tidigare så är ju detta webbinar delvis på engelska. Både Albert och Liubov kommer prata och svara på frågor på engelska. Och jag och Pontus vi kommer översätta och göra vårt bästa för att det ska bli så tydligt som möjligt. Vi kör som tidigare. Är du inloggad med ett Google-konto så kan du chatta direkt i sändningen. Är du inte inloggad så kan du skicka sms till mig om ni har några frågor och då är telefonnumret 0709 62 11 26. Och annars så ställer ni ju frågorna i chatten direkt. Och precis som tidigare webbinar så kommer även det här att spelas in och läggas upp på vår YouTube-kanal som heter Huber Nordic. Pontus, du kan väl börja med att gå igenom dagens agenda och målet med dagens webbinar lite kort.
Ja. Kortfattat kan man säga så här att detta är ett uppföljningswebinar på det som vi kallade för slamtorkning, första steget mot framtiden. Så först så kommer vi prata lite kortfattat om varför vi är här och dra igenom sammanfattningen för det webbinariet. Sen så kommer vi dyka lite djupare i varför vi ska torka och bränna slam och efter det så ska vi se vad vi kan göra med askan.
Spännande. Då kan väl du ta och börja med sammanfattningen från det förra webbinariet helt enkelt.
Ja. Kortfattat då så ska vi göra något som blir hållbart och säkert för framtiden så är slamtorkning det första steget. Växthusgaser som metan, lustgas släpps inte ut i atmosfären. Antalet transporter kan minska med upp till 80% om logistiken blir rätt. Torkat slam är hygieniserat och kan spridas och användas på mark enligt dagens bestämmelser. Slammet är lätt att sprida i och med att det är pelleterat redan efter torkningen. Torkning och förbränning finns idag och det finns många referenser med goda resultat. Torrt slam är ett av framtidens biobränslen och slamtorkning och förbränning möjliggör återvinning av fosfor upp till 90%. Alltså till och med mer än 90% tror vi. Eller det kan nog Liubov förtydliga senare. Slamförbränningsanläggningar kan också skapa fjärrvärme och bli snabbt energipositiva.
Okej, men varför ska vi då bränna slammet, Pontus?
Ja, låt oss då säga att på sikt så kommer vi få en ändrad lagstiftning där vi tillåts sprida en liten del på åkermark. Men vi måste då fortfarande ta hand om 600 000-800 000 ton slam som idag inte har något hem. Och för att göra det på ett säkert sätt med fosforåtervinning så krävs det någon form av förbränning eller omhändertagande av askan. Och det är där vi ska landa idag. Varför vi ska göra detta.
Ja.
So I was just shortly here explaining that I consider also mono-incineration to be the most effective way and the most sustainable way to handle sludge. Albert, can you explain a bit? I mean, you have done extensive investigation on municipal sludge. Can you in short terms just describe why municipal sludge no longer are allowed to be spread on farmland in Germany and other parts of the European Union?
Yes, it's a question of the protection of groundwater. You know that sludge is a sink for harmful substances, and if sewage sludge is used as a fertilizer on the fields, these substances penetrate into the groundwater. This is one reason why in Germany we went away from using sewage sludge as a fertilizer on the fields. And the other reason is there is a very good substance in the sludge. This is phosphorus, and this can be recovered from the ash very easily. And the efficiency of recovery is more than 80%. And if we look at this central picture, we have one version of a combination of sludge drying with mono-incineration. And here we have the picture which is commonly used in bigger sludge incineration plants. You have on the left side with the green container where the dewatered sludge is delivered and pumped to the disc dryer, and the disc dryer dries the sludge from a DS content of, let's say, 20 to 30% to around 35 to 45%, depending on the calorific value of the sludge. And with this DS content, the sludge can be incinerated in a fluidized bed incinerator, which is the central cylinder autonomically. That means that there is no extra fuel necessary for the incineration. And in the second step, you use the energy which is in the exhaust gas for preheating the air of the fluidized bed incinerator, and also for the drying of the sludge in the disc dryer. And of course, some harmful gases which are included in the exhaust gas have to be removed before the exhaust gas is released to the surroundings. And the ash which is collected from the grid can be used as a fertilizer when it is processed in further steps. And the ash of the filter has to be deposited, because at the filter ash, which is a very fine ash, very small particles, the heavy metals like mercury agglomerate.
Yeah, we can look into that a little bit further later. And I mean, I know that you have the mono incineration has been compared and investigated to other possible ways of recovering phosphorus. Can you please describe a little bit why mono incineration has been pointed out as the best option for phosphorus recovery?
Yeah, the major point is the efficiency. If you take out the phosphorus from the liquid phase or from the sludge on the wastewater treatment plants, the efficiency never exceeds 45 to 50%. But if you use the ash from a mono incineration plant, you can extract more than 80% of the phosphorus entering the wastewater treatment plants.
Okay, yeah. Interesting. Do you have any comments on this, Liubov?
No.
No? Okay. So that also brings us up to the European fertilizer regulation. I will shortly run through this in Swedish, and then Albert will describe the fluidized bed technology, and we'll also look in furthermore to the sludge to energy process. Så på svenska då, detta är liksom ett uppdaterat utkast av den förordningen som vi har, där man har då försökt att få till att pyrolys och gasifieringsprodukter ska bli inkluderade så man kan använda dem i gödseltillverkning. Det som har hänt då, det är väl att man har gjort det på biokol, men man kan inte definiera slamkol som ett biokol, och därför har det blivit uteslutet då, tillsammans med industrislam, mudderslam och kommunalt avfall som inte är då tillåtet, och detta börjar gälla den 16 juli i år. I just mentioned here that the European Parliament have amended the legislation of adding pyrolysis and gasification materials to the EU fertilizing products. Municipal sewage sludge is excluded and not allowed. What is the main reason for that, Albert?
Could you repeat your question? What is the main reason for what?
Yeah, the sludge. The European Parliament have just amended their legislation on adding the pyrolysis and gasification materials to the EU fertilizing products. And municipal sludge and industrial waste, also dredge sludge, has been excluded and are not allowed to be processed and then used in fertilizing products. Can you comment on why?
Processed by pyrolysis or what?
Yeah, exactly. Sorry.
I can only talk about the experience we have in Germany with pyrolysis and gasification units aside the typical incineration plants. And the pyrolysis process is, let's say, described by heating of the sludge with excluding the oxygen. And this process results in three different agents. So this is the gas, and there is some liquid phase, and there is a coke. And the coke still contains up to 30% of organic materials or carbon. In Germany, a lot of, let's say, examination have been made with regard to the application of this coke, and it turned out that is not comparable with, let's say, the ash coming from the incineration plant, where the carbon residue is far less than 3%. And as far as I know, there is no, let's say, application of coke from pyrolysis for fertilizer up to now. And in the German regulation for fertilizers, only the ash from the incineration, mono incineration of sewage sludge is allowed to be used as a fertilizer, either directly or in a processed form where further ingredients are added to get a full fertilizer.
Yeah. So okay, that's probably why they have excluded it. And I also heard that they are looking for mechanical processes and not chemical processes. And we definitely have some chemical processes in the sludge. So let's move over then to why we can consider sludge as a good biofuel for the future. Albert, we need to dry the sludge before we burn it. Why do we do that?
There are two different methods of handling the sludge. The first version is as it is executed in the S2E plant in Hollelocha, which is in operation now. This is a full drying of the sludge, but only a portion of the sludge is dried, and the dried sludge is mixed with the dewatered sludge immediately in front of the incinerator to get these 45% of TS. Yeah. This combination is normally used for smaller plants, and its big advantage is that this is very flexible in accepting dewatered sludge or partially dried sludge or fully dried sludge. And the other version we saw is the combination of disc drying and partial drying of the whole sludge mass to 45% TS and direct feeding into the mono incineration. Yeah,
yeah. And the picture here describes the different matters of the DS. Can you elaborate on that?
This is the effect of the organic content. And the DS content to the sludge is dewatered, and you see on the right upper side it guarantees a self-sufficient incineration. That means you can incinerate the sludge, for example, if it had an ODS content of 60% and a DS content of 20 and 28%. That means the calorific value of the sludge is high enough to get a self-sustaining incineration in a fluidized bed incineration. On the other hand, if the ODS is smaller and the dewatered sludge has a lower DS content, you have to add additional fuel like oil or gas for the incineration.
Okay. Okay. So let's have a look at the fluidized bed oven. Can you just walk us through the different steps of the oven?
Okay, you see this fluidized base incinerator. It has, let's say, a fuel supply for starting the incineration process, and you have to imagine you have a big mass of sand inside, and this is fluidized. That means heated air is coming from top to bottom, from bottom to top upwards, and fluidizes the sand, and only 3 to 5% of the mass is introduced as dried sludge. And you have two, let's say, areas. The one is the fluidized bed area, the wirbel bed or fluidiserat bed. And here we have a temperature set of 700 to 800 degrees Celsius. And the second section is the overhead bed, and where you have higher temperatures of 800 to 950 degrees Celsius. And the sludge is spread from the left side, having a DS content of 40 to 50%. This is either done by a special rotating wheel, or it is done by steam-operated tubes. And it is essential to keep these temperatures with regard to the gases which are in the exhaust air. You have to imagine sludge has some nitrogen content, and this nitrogen is transferred in the fluidized bed to some N2O, the nitrogen oxide. This gas is harmful to the climate. It has a very big influence on the climate, and therefore it has to be destroyed in the headspace with higher temperatures. So it is of utmost importance to have two temperature sections with regard to the exhaust air treatment.
Okay, thank you. So what I will do now is to give a short explanation on the whole energy to sludge to energy process, and that was what Albert was explaining before. And shortly, slammet lagras alltså i en silo som sen man tar då till en bälttork eller till en roterande disktork. Efter det, och en bälttork torkar till 90 TS, en disktork torkar till 45 TS, och därefter förbränns det. Och för att få då den här optimala förbränningen så behöver man ha ett TS-halt på mellan 45 till 50. I de olika stegen som ni ser här, där jag har skrivit gråa små boxar, så kan man plocka ut fjärrvärme, men man kan även plocka ut el på vissa ställen. Så att efter torken, efter gasturbinen och i sista steget på rökgasreningen kan vi plocka ut fjärrvärme. Vi brukar säga att ungefär mellan 25 till 30 000 ton avvattnat slam krävs för att man ska få en sån här anläggning energipositiv. Och den rökgasreningen vi har idag, den är väldigt effektiv. Så vi vet att de kraven som ställs, de upprätthåller vi. Har vi fått
ja, jag har en liten fråga från publiken här, och då är det: vad är det som avgör vilken tork man använder?
Det handlar om logistiken. Jag tror mig att när vi pratar Sverige då, som har väldigt stora avstånd, så kommer vi hamna i ett läge där man vill inte frakta så mycket vatten helt enkelt. Vatten vill man ju inte frakta, och då blir det att vi kommer torka lokalt eller semicentralt. Så att, och sen så en disktork, den är också avsedd för stora volymer, riktigt stora volymer. Så att har man en direkt innan en förbränningsanläggning med mycket volym, då vill man gärna se att det är en disktork som står där som gör den direkt till 45 TS. This is the process, and now ja.
Wir könnten natürlich auch nochmal Industrie fragen, also den Flug über sagt.
So let's look what we can actually gain out of the ashes. Så nu behöver vi titta lite närmare på vad får vi ut av den här askan som vi får ut.
Just det.
Och
10 ton tunnslam blir alltså 23 till 24 kilo gödsel med 17% fosforinnehåll.
Precis. Det innebär så att enligt bilden som ni ser här, så enligt Easy Mining så kan de få ut 17% fosforinnehåll i askan. Och nu tänkte jag att you, Liubov, can go through the process that you are doing.
Yes. Well, first of all, I would like to show a bit the pattern of how the phosphorus is being consumed within the European Union today, and give a perspective on how it can be done in the future. So, as it can be seen on the left picture, about 15% of the fertilizers that are used within the European Union are being imported, while the rest is produced internally. However, at the same time, about 90% of the raw material for such productions are imported from the outside, and only 10% are located in the European Union, specifically in Finland. So this shows a really high dependency of the European Union on the import of phosphate rock, which together with white phosphorus has been added to the list of critical raw materials. And at the same time, phosphorus is a vital nutrient that has no substitutes and linked to global food security. And through the food chain, after being used as a fertilizer or feed additive for food production, it ends up in the wastewater and then transferred into the sewage sludge. So within the European Union, about 48% of sewage sludge is spread on the farmland in order to recycle nutrients from it. However, due to the certain restrictions with the quality of the sludge and the availability of the farmland for the spreading, a large portion of sewage sludge ends up on the landfill or is being sent for thermal destruction through incineration. And as it has been mentioned, the organic compounds, contaminants, and also the pathogens from such sludge are being removed during the mono-incineration, and also the volume is decreased drastically, which ensures the increase in concentration of phosphorus and makes it a good source for potential phosphorus recycling. So in this case, a circular solution can be created where the recycled phosphorus can be then again be returned for production of the food.
Oh, very interesting. Yeah. So can you shortly explain your process?
Yes. So the ash-to-phos technology that has been developed in Easy Mining uses sewage sludge ash as an input material for recovery and extraction of phosphorus and other elements such as iron and aluminium in order to convert them into the valuable products again. So it starts with extraction of the elements in the acidic step where they are leached from the ash. And in this step, the first product is being produced, which is called silicate sand. This is an ash residue which has a lower content of metals and of phosphorus compared to the ash itself. And it makes it a more suitable product to be used in a construction industry, either as cement replacement or as sand.
Okay.
Yes, and other elements that have been leached from the ash are then separated in the alkaline step into intermediates that can be converted into the final product. So iron and aluminium are recovered as iron chloride and sodium aluminate, which are quite known on the market as precipitation chemicals for water treatment and can be returned into the water treatment plants. While phosphorus is being recycled as precipitated calcium phosphate, that is also a known product on the fertilizer market, so can be used as a fertilizer. It has also a similar chemical composition as apatite that is originally used for the production of fertilizers and feed additives, so it can be used as a substitute for such productions as well. And hopefully in the near future it will also be able to be used as a feed additive itself. And the important point is also that while phosphorus concentration in the ash increases, so does the concentration of heavy metals compared to the sludge itself. So when such processes are implemented, it's important that they are able to detoxify the final phosphorus product and separate the heavy metals that are being extracted from the ash into a separate stream, prevent it from following the phosphorus product, and in this way the waste reduction is achieved.
Great. It seems like the whole circle, and you are actually recovering a lot more than just the phosphor.
Yes,
yeah.
Indeed.
So we are gaining back a lot of materials in this way.
Yes.
Yeah, and as I understand, the ammonia incineration takes away the medical residues and also the microplastic, which is also good. All right, thank you very much. And what kind of projects do you have ongoing at the moment?
Well, currently we have two projects based on ash-to-phos technology ongoing. One of them is a plant to be built by a joint venture between the company Gelsenwasser and Easy Mining in Skapa in Germany. And for this project we have completed the basic engineering and now in the process of applying for the environmental and building permit. Okay. And the second project is for the plant that will be fully owned and operated by Randcells, and it is to be built in Helsingborg. We are also now in the process of waiting on the permit decision, which is supposed to come back by the end of this year.
Okay.
Yes.
Yeah. All right. Perfect. Thank you very much.
Thank you.
So, Nina, I think we are about at the end.
Maybe we should see if we have some questions.
So basically we have...
Vi har faktiskt inga frågor.
Inga frågor? Nej.
Inga frågor.
Okay.
Allt måste vara fullkomligt glasklart.
So then we ask Albert, do you have any questions for Liubov, for example?
We have in Germany a lot of different systems for the phosphor recovery because it was supported by different states in Germany, but only a few are now on the way to industrial production. One is just shown here in the lecture. Other one is installed in Haldensleben in Lower Saxonia or Saxon-Anhalt. This is just with thinning of the ash with acid, suspending it, and spray granulating it. This is not with removal of heavy metals, but it's a very simple system, and this plant has already been commissioned this year, and this is already in full production. And the other option is producing phosphorus acid as a very, let's say, flexible agent to be applied in different industries.
Okay.
Mm-hmm. Yep. Okay, so no question, but just... nej men jättebra, då tänker jag att vi kan summera lite, Pontus.
Yes.
Ja.
Kortfattat då. Anläggningar kan skapa fjärrvärme och vid rätt dimensionering så är de energipositiva. Ur bäddaskan kan vi få återvinna fosfor i ren form. I filteraskan kan vi plocka bort farliga metaller och vi kan även återanvända dem som resurser. Vi vet att läkemedelsrester och mikroplaster försvinner i förbränningen. Och med den här metoden som Easy Mining har så kan vi återvinna över 80%, kanske till och med upp till 90% av fosfor. Monoförbränning vid monoförbränning får man tillbaka en aska som är godkänd och den funkar för att återvinna fosfor. Slamaska finns det väldigt låga nivåer av kadmium. EU anser inte att pyrolyserat avloppsslam, slamkol, är en tillåten produkt för gödselproduktion.
Just det.
Och med det så vill vi egentligen tacka för idag. Och har ni några frågor så får ni gärna skriva dem direkt till mig. Och vi finns där om ni har några funderingar eller någonting. Så med det så tackar vi för idag. Du ska berätta lite om just det.
Det här var ju det sista webbinariet för våren. Vi tar en paus nu i sommar och fortsätter till hösten igen. Då kommer det bland annat att komma ett webbinar där vi pratar om lösningar för slambehandling i samband med fiskodling eller slakteri. Och det kommer jag göra tillsammans med min norska kollega Elvis. Och fram till dess så tänker jag att vi önskar er en glad sommar och ta hand om varandra.
Ja. Glad sommar. Tack ska ni ha. Hej
Hej.
Thank you. Bye bye.
Thank you.